is Salma Amr, and you are watching Asteroids. The universe that we live in is colossal. Too large to fully wrap our heads around, and it still continues to grow and expand to this day. In relation to its size, we are merely a speck of dust. And with this in mind, what if I tell you that we might be even smaller than that? That our universe might just be one of many universes out there. Introduced by a grad student named Hugh Everett in 1954 and featured in various forms of science fiction entertainment since then, such as Doctor Who and Star Trek, the multiverse theory has been heavily discussed by astronomers and physicists as to the possibility of its existence. It's quite the controversial topic, with many people on both the supporting and opposing sides of the argument, mainly because we have no way of properly testing it or proving it to be true. It's due to this that the idea of a multiverse cannot even be considered a true theory, because in scientific terms, a theory is a thorough explanation or proposition about observations made about the natural world, supported from evidence discovered through the scientific method. Actually, various forms of the multiverse that have been considered. Everett's idea in particular follows the theory of quantum mechanics and is known as the quantum multiverse, in which every potential outcome for each of our decisions, even the ones that don't happen in our own world, are actualized in other universes. Say, for instance, that after waking up in the morning, you're faced with a decision of what color shirt to wear, as we all do. With this concept, there are a range of potential universes featuring all of the possible results. Like, perhaps you chose to wear black in this world, but in another universe you decided on blue, and in another one you are wearing yellow, and so on. With this very simplified example of the quantum multiverse in mind, it is important to remember that these varying outcomes would extend all the way back to the beginning of time, and impact other things as well. Like, while there are a range of universes in which you woke up today and chose a specific colored shirt to wear, there might be universes in which you don't even exist at all as a result of prior events. The study of quantum physics began in the year 1900, when Max Planck first introduced the concept to the scientific community. Planck's studies of radiation propelled some really interesting discoveries that conflicted with the laws of traditional physics. These discoveries suggested that there are different laws in this universe that operate at deeper levels than those we already know. Physicists who studied quantum levels noticed strange things about this world. First, the molecules at this level arbitrarily take different shapes. For example, scientists have observed that photons, or small packets of light basically, act as particles and waves. Even a single photon does this rotation between states. Imagine that you outwardly behave like a human being when your friend looks at you, but then when he turns right around, you suddenly, poof, become gas. This interpretation was put forth by Danish physicist Niels Bohr, who said that quantum particles do not exist in one particular state or another, but in all of these possible states at the same time. The sum total of the states of a quantum object is called the wave function, and the state of an object in all of its possible states simultaneously is called the superposition. Everett, for the most part, agreed with what Niels Bohr proposed about the quantum world. He agreed with the idea of the superposition and also the idea of a wave function, but Everett disagreed with Bohr on one vital point. For Everett, measuring a quantum object does not force it to take one or another condition. Instead, measuring a quantum object causes a real branching of the universe. The universe is completely copied into two universes, and each of the two universes represents a possible result of the measurement. For example, suppose a wave function of something is both a particle and a wave. When a physicist measures this object, there are two possible outcomes. Either that object is observed as a particle or as a wave. As exciting as it may sound, Everett's multiple worlds theory has implications beyond the quantum level. If an event has more than one possible outcome, then, if Everett's theory is correct, the universe will branch out when this event occurs. This really happens even if the individual chooses not to do anything, and this means that if you are exposed to a situation in which death is a possible outcome, then in another universe parallel to us, you're basically dead. But a person cannot be aware of his other twins or even his own death in a parallel universe, so how do we know that this theory is correct? This theory is actually theoretically possible, and it technically occurred in 1933 through a really famous intellectual experiment. This leads into the famous paradox known as Groningens Cat. As you all might already know, Schrödinger had people imagine that a cat, a poison, a Geiger counter, a radioactive material, and a hammer were all inside of a sealed container. And the amount of radioactive material was minuscule enough that it only had a 50-50 shot of being detected over the course of an hour. If the Geiger counter detected the radiation, then the hammer would smash the poison, effectively killing the cat. And until someone actually opened the container and observed the system, it was impossible to predict the cat's fate. So, until the system collapsed into one configuration, the cat would exist in some superposition, zombie-like state of being both alive and dead. For explanation and information on Schrödinger's experiment, you can watch the video that will link down below in the description box. Quantum mechanics isn't the only field of physics that is looking for the answer to this question, and this is where string theory comes in. After his famous theory of relativity, Albert Einstein spent the rest of his life searching for the final level that would answer all physical questions. Physicists refer to this theory as the theory of everything, and quantum physicists believe that they are actually on the way to discovering this final theory. But another field of physics contradicts this and believes that the quantum level is not even the smallest level, and therefore it cannot provide us with a theory of everything. Instead, these physicists have turned to a theoretical level below quantum called string theory in order to answer these questions. The surprising thing is that these physicists, during their theoretical research, also deduced, like Everett, the existence of parallel universes. String theory was established by the Japanese-American physicist Michio Kaku, and his theory says that the basic building blocks of all matter and of all the physical forces of the universe, like gravity for instance, are at a subquantum plane. These building blocks resemble very small rubber bands, or strings, that make quarks, otherwise known as quantum particles, and follow electrons, atoms, cells, and so on. And these determine exactly what kind of material is produced by the strings, as well as the behavior of this substance according to the fluctuation of these strings. The strings vibrate and give rise to the different forces ruling the universe. This way, our entire universe is basically music. According to the string theory, this playing takes place across 11 different dimensions, including the 3 that we can see. Like the theory of multiple worlds, the string theory reveals the possible existence of multiple universes. These dimensions wrap around themselves so that we don't even realize them in our own world. Since the universe contains these different dimensions with their many and varied geometries, and knowing that the laws of nature depend on the geometry of said nature, it is expected that these many dimensions will form different universes in their laws and facts. Thus, string theory leads to the conclusion that there are possibly very many different universes. Additionally, Kaku points out the fact that billions of solutions to string theory equations have been discovered, and each of these solutions describes a mathematically consistent universe, and is different from all of the other universes described by other solutions to the theory. Thus, string theory indicates the possible presence of multiple universes. According to the theory, we are like a bubble next to similar parallel universes. In contrast to the theory of multiple worlds, string theory assumes that these universes can actually communicate with each other. It also says that gravity can flow between these universes. And when these universes actually interact, a big explosion arises, such as the one that created our own universe. When physicists are capable of making a machine that can monitor quantum materials, the strings below the quantity will remain out of observation, and this makes them, and thus the entire theory based on them, entirely theoretical. Some have rejected this, and others have believed it to be true. A scientist named Max Tegmark examined the physical theories involving parallel universes, which form 4 hierarchical natural levels of multiverse existence, in such a way that diversity increases as we advance. For further info about these levels, you can watch another video that we've linked down in the description box below. We'll discuss the secret of hidden matter. In cosmology, this invisible matter appears to be about 90% of the universe's mass, and although it's not visible, scientists have recognized its existence due to the strength of its attraction. Hidden matter might be present in parallel universes as well, and such matter affects the universe in which we live through the force of gravity, which, according to string theory, can also flow between parallel universes. This material is hidden because our photons stick to our membranes, and thus photons cannot travel through the vacuum from the parallel material to our eyes. Pretty cool, right? There are various religious perspectives towards the concept of the multiverse. It can be found in Hinduism, Buddhism, Mormonism, and even possibly in Islam as well. Some Muslim philosophers have cited specific ayat in the Quran that might hint towards the possible existence of a multiverse. One such verse is the 3rd verse of chapter 67, which states, "He, God, who created the 7 tournaments or heavens, one imposed over the other." And this verse says that each heaven or sky has its own order, possibly meaning laws of nature, which also discusses these 7 heavens, also mentions similar earths. So the 12th verse of chapter 65 states, "It is God who has created 7 heavens and of the earth the like of them." Although this is definitely not really definitive evidence, we're not really completely sure completely sure if this is what exactly the verse is trying to hint at. It's still really interesting to think about. So that's about all that I have for you guys today. So thank you all for watching. Stay open-minded, keep on asking questions, and until next time.